Hello, Bacho. So, I'm Siddharth, and today we are going to discuss part test 7. And we are having here, let's start. First question. So, it says frequency of the fundamental tone in an organ pipe is 320 hertz. The speed of the sound is 320 meter per second. The frequency of the fundamental tone in a closed organ pipe will be. So we already know that in open organ pipe, the fundamental frequency is V by 2L, and which is given to us, right? It is given to us 320 hertz. In the closed organ pipe, the fundamental frequency is V by 4L, which is basically 1 by 2 of V by 2L, correct? So it would be 320 by 2, 160 hertz. So this will be our correct option. Let's go to the question number 2. Here we are able to see two identical sonometer wires have fundamental frequencies of 500 hertz. When kept under the same tension, what fractional increase in the tension of one wire would cause an occurrence of 5 beats per second? So basically there are two wires, correct? And these two wires are identical. Basically they are having same mu. So can we say that the frequency, fundamental frequency would be 1 by 2L of root T by mu, correct? Now they are saying if we are increasing little bit tension there, so the frequency is increasing and it is producing 5 beats. So what would be the change in frequency? It could be F plus 5. So it would be 1 by 2L root tension is little bit changed. So I am writing T plus delta T by mu. Now this is my equation number 1. This is my equation number 2. Can I divide my equation number 1 with 2? Or let's divide by 2 with 1, correct? So if we divide, we are going to get F plus 5 by 5, and I'll be getting T plus delta T by T and root of it. So here I get 1 plus 5 by F, and here I am going to get 1 plus delta T by T. If I square both sides, I'll be getting this. Now can I say that frequency here is how much it is given? 500. So I'll write 500. I know that 1 plus 5 by 500 will be, in comparison to 1, it would be too small. So I can just write 1 plus x to the power n as 1 plus nx, right? We all know. So it could be written as 1 plus 10 by 500, which would be written as 1 plus delta T by T. Now fractional change in tension could be written as, which is 1 by 50, which is 0.02. Let's see. They asked us what would be the fractional increase in tension, correct? So option 2 will be our correct answer. Now the next one we are able to see here is two identical glass bulbs are interconnected by a thin glass tube. So we can see there is two glass bulbs are there interconnected by a thin glass tube. A gas is filled in these bulbs at NTP if one bulb is placed in ice. So in the beginning, everything is at the same temperature. So this is in the beginning, this is bulb number 1, this is also bulb number 2. And in the beginning, this is also at 0 degrees Celsius, this is also at 0 degrees Celsius. And after some time, this is placed into ice, which is at 0 degrees Celsius. And this is placed at some temperature T that we do not know. So they are saying that pressure is increasing, it is becoming 1.5 times of this, condition 1. The temperature of the hot bath will be. So we are able to understand one thing. Initially, whatever is the number of moles in this, finally also the number of moles will remain same, or the molecules, because we are able to see that pressure is changing, temperature is changing, but the number of molecules or the moles will remain same. So can I say this will be n plus n, n1 plus n2? What is n would be here? It would be PV by R, and 273, that is the temperature. This will be PV by R, 273, that is the temperature. Here it is going to become 1.5 P by R, that is 273, because it is at 0 degrees Celsius, plus this will be 1.5 P, sorry, V here also, and here we are going to have T plus 273, correct? So we can cancel out PV by R, PV by R, PV by R, PV by R. Here I'll be having 2 by 273 and 1.5 by 273. So it will be 1 by 2 into 273 equals to 1.5 divided by T plus 273. So if I solve it, I'll be able to get 1.5 times multiplied by this. I'll be getting T equals to T plus 273 as 819 Kelvin. So temperature here would be 546. Correct? So this is my correct answer. Next question. Two strings of copper are stretched to the same tension if the cross-sectional area are in the ratio 1:4. The respective wave velocities is. But show the wave velocity is given by, in the string it is given by root T by mu, correct? So now they have given area. So can I write mu as mass per unit length, which is mass per unit length? If I multiply it by area up down, I'll be getting here mass by volume into area, which is basically density multiplied by area. This is my mu. So my wave velocity becomes here root T by rho A. Can I write it as V1 is, this will be 1 by, tension is not changing, same tension, rho is not changing, so can I write A1? So it would be V1 by V2 would be root of A2 by A1. Now it is going to become root of A2 by A1, area is 4:1. So it would be 2:1, correct? So 2:1 would be my answer. Next one. The pressure and volume of a given mass of a gas at a given temperature are P and V respectively. Keeping temperature constant, the pressure is increased by 10%. Okay, these kind of questions you would have known. Like there is a guy, he goes to an interview, increases the salary by 10% and decreases the salary by 10%. So same kind of question here. We are able to see that PV is equals to constant. If PV is constant, can I say that pressure once increased by 10%, it is going to become basically P plus 10P by 100. So it is going to become 110P by 100, correct? Now they are saying decreases by 10%, so it is going to become 11P by 100, correct? So it is going to become now 99P by 100. So basically my pressure is decreasing by almost 1%. So my volume is going to increase because PV is equals to constant. So I have here more than V. Then I have next question, which is if two tuning forks A and B sounded together, they produce 4 beats per sound. A is then slightly loaded with wax. So basically there is 2 tuning forks are there. Let's call them A and B. They have given the frequency of A is 256 Hertz. Now they are saying they are producing 4 beats per second. So either it could be 260 or it could be 252. Now if we are going to load A with wax, basically the frequency of it has to decrease. If it is decreasing, and let's assume the answer is 260, the beats are going to increase, but they are saying it is producing only 2 beats. So basically this, if the frequency is decreasing, it might be 252 and this might be something less than 256. So again they are going to produce 2 beats. So our correct answer is going to become 252. Next one is to decrease the fundamental frequency of the stretched string fixed at both ends. One might, we know that fundamental frequency of a string is given by 1 by 12 root T by mu, correct? So now obviously increase its length, frequency is going to decrease, right? So C will be the correct one. Why does the pressure of an ideal gas increase when it is heated at constant volume? Alright sir, gas molecules expand, molecules move at the same speed but hit the walls more often. Molecules move faster and hit the walls more often, because when we are going to heat something at constant volume, basically we have done a derivation in the KTG where at the constant volume we are giving some temperature and we are calculating the average kinetic energy. So C will be the correct answer here. Molecules move faster and hit the balls more often. Now we are able to see question number 9. CO2 is a linear triatomic gas. Triatomic molecule, the average kinetic energy at temperature T will be. So we know that the degree of freedom for the linear polyatomic gas is basically 5. So the average kinetic energy is going to become 5 kT by 2. Next one, when open pipe is closed from one end, the third overtone. Let's write formulas once. For open pipe we already know. For open pipe we know n plus 1 harmonic is basically our nth overtone, correct? And for closed pipe it is 2n plus 1 harmonic is nth overtone, correct? Let's read the question again. So they are saying when open pipe is closed from one end, then third overtone of the closed pipe. So basically third overtone, correct? Third overtone of a closed pipe is higher in frequency by 150 Hertz than the second overtone of the open pipe. So third overtone of closed pipe, correct? This is closed pipe. On the other hand we have 150 plus, and that is, they are saying that second overtone of open pipe, correct? Now 150 plus second overtone of open pipe is going to become, if we want to calculate second, it will be basically third harmonic and it would be 3V by 2L. And this is going to become third overtone of a closed pipe. This will be 3 2s are 6 plus 1 7. So 7V by 4L. So here we are going to do 150 equals to 7V by 4L minus 3V by 2L, which is basically 4L, 7V minus 6V. So here we are going to get 150 equals to V by 4L. Now this is the frequency of our closed pipe. Now we want to calculate for open pipe. For open pipe we know that we want to calculate V by 2L. So V by 2L is going to become basically 300. So D will be the correct option. Now question number 11. A sample of gas expands from volume V1 to V2. The amount of work done by a gas is maximum when the expansion is isothermal, because we know Q equals to W. Basically all the energy that you're giving is used for only two things, that is to increase the internal energy and do some work done. If you want maximum work done, basically you're not spending any energy in the increasing in the internal energy of the gas. So basically isothermal process. So we are able to see question number 12. Two waves are superimposed whose ratios of intensities are 9:1. Acha, the ratio of maximum and minimum intensity is. So we already know that intensity is having a relation with amplitude. It is intensity is directly proportional to A square. So can I write A1 by A2 square, which is 9:1, which is A1 by A2 root of it. So it would be 3:1. A1 is to A2, correct? So can I write it as 3A2 equals to A1? So It is 9 is to 1, sorry, my bad. So it is 9 is to 1, I1 is 9, and this is correct. So this is my, now they are asking maximum and minimum intensity. So what is my I max by I minimum? I max by I minimum would be A1 plus A2 whole square by A1 minus A2 whole square, correct? So I max by I minimum is going to become, what is my A1 plus A2? It is going to become A1 is 3A2 plus A2, 4A2 by A1 minus A2. So 3A2 minus A2, 2A2, and this will be square. So this is going to become 2 square is 4. So I max to I minimum, I max to I minimum is going to become 4 is to 1. So that will be my B option. Now question number 13. Let gamma 1 be the ratio of the molar specific heat capacity at constant pressure and molar specific heat capacity at constant volume for monatomic gas. So what is gamma 1 for us? Sir, gamma I know it is 1 plus 2 by F, but since it is a monoatomic gas, it could be 1 plus 2 by 3, which is going to become 3 plus 2, 5 by 3. Now gamma 2 is going to become 1 plus 2 by F, and it is now for diatomic gas, so it will be 1 plus 2 by 5, it would be 7 by 5. Now they are asking gamma 1 by gamma 2, so which is 5 by 3 into 5 by 7, which is going to become 25 by 21, which is option B. Too many option B's, huh? Alright. So, what is the next question we have? Question number 14. In an isothermal change, the change in pressure and volume of a gas can be represented for three different temperatures. T3 is greater than T2 is greater than T1. First thing, sir, PV equals to constant. I am able to realize that this is incorrect, this is incorrect, because the graph will be hyperbolic and it will come something like this. So these two could be correct. So how would I know, sir? PV is directly proportional to T, or PV equals to constant, because it is an isothermal process. I know that the distance from the origin of distance of the curve from the origin will give me the basically temperature. So can I say that the one which is having higher temperature will be basically farthest? So T3 is here, so my C option is correct. Next one. A body cools in 7 minutes from 60 to 40 degrees Celsius. Usual question, right? So we remember theta 1 minus theta 2 by T alpha, and theta 1 plus theta 2 by 2 minus theta S. Theta 1 and theta 2 is basically temperatures, alpha is our constant, and theta is the surrounding temperature. So we are able to see that theta 1 is 60 and it is going down to 40. And how much time it is taking? 7 minutes. So alpha is there, 60 plus 40 will be 100 by 250 minus surrounding temperature is 10. So I am able to calculate from here, this is 20 by 7 and it would be alpha, and this is going to become 40. So this is my 2, alpha is 1 by 40. Very good. So now can I apply again? They are asking me temperature of the body next 7 minutes. So now the body is already at 14. Now again it is going to decrease to some temperature. So it is going to become 1 by 14. It would be 40 plus theta by 2 minus 10. Now this becomes 7 2s are, this becomes 80 minus 2 theta equals to 40 plus theta minus 20 by 2. So this becomes now 160 minus 4 theta equals to 20 plus theta, which is basically 140 equals to 5 theta, where theta would be 140 by 5. I think 28 should be our answer, correct? Now we are having the ratio of the speed of the sound in hydrogen gas to the speed of sound in oxygen gas at the same temperature is. What is the speed of the any gas in medium is, or gas depends upon its gamma and its molar mass. So we are having it at the same temperature, so T is constant, R is constant. Gamma, since both are diatomic gases, that is also constant. So we are going to have here V1 by V2 equals to root of M2 by M1, correct? So that is going to become M2 for the oxygen. It is going to become 32. Hydrogen it is 2. So it would be root 16 by 1. 4 is, sorry, root 16 by 1. So it would be 4 is to 1. Should be A. Next question, the thermodynamic process in which internal energy of the system remains constant. Internal energy of the system, that means it is an isothermal process, because we are not changing the temperature of the gas. Question number 18, a gas mixture consists of 2 moles of oxygen and 4 moles of neon. What is the internal energy formula, bachcho? NF by 2 RT plus, this is N1 F1 by 2 RT plus N2 F2 by 2 RT. Correct? We know that if there are two gases are there, internal energy will be basically sum of individual internal energies, right? So that's why we are putting total. So now N1 is how much? 2 moles. Degree of freedom is how much? For diatomic gas, right? So 5 by 2 RT plus, this is 4 moles monatomic gas, 3 by 2 RT. This is going to become 5 RT plus, this is going to become 6 RT. So this becomes 11 RT. Nice. We got our answer as B. Next one, the average kinetic energy of a monatomic molecule. Oh, big numbers. Alright. So what is the average kinetic energy we have? Kinetic energy for a molecule is given as 3 kb 3 by 2 kt. Correct? So they have given us now 0.414. First convert it into joules. So this will be minus 19 and this will be 3 by 2 into 1.38 into 10 to the power minus 23 into T. Looks like a big number. Are we scared by big numbers? So we are going to do calculation of this, and let me do just the calculation. And after calculation, if we do 0.414 multiplied by 1.6 and multiplied by 2 divided by 3 and 1.38, we are getting temperature as 3200 Kelvin. Do we have option? Yes. So next one, parameter that remains the same for molecules of all gases at given temperature. For all gases at a given temperature, the kinetic energy will remain same. Momentum, speed, mass, all are going to be, can be different, है ना? So now next part of the question, next part of the paper, which is if fundamental frequency of closed pipe is 50 hertz, second overtone. So far we are pro in this now. So second overtone means, second overtone is basically, we remember the formula, it is 2n plus 1th harmonic, yes or no? Now second overtone will be 2 2s are 4 plus 1, 5 fifth harmonic. So 5 by 4 VL is basically they are asking, correct? Frequency of that they are asking now. This is the frequency they are asking. Now V by 4L is given. Fundamental frequency is 50. So 5 into 50, it is going to become 250 hertz. So answer should be 250 hertz. Next one. A tube closed at one end and containing air is excited. It produces the fundamental note of 512. If the same tube is open at both ends, the fundamental frequency that can be produced. So it is open at one end. That means closed tube hai, right? And it's fundamental. So closed ka frequency kitna diya hai bachche? Closed tube fundamental frequency is V by 4L and it is given as 512 hertz, correct? It is given as 512 hertz. So now we are looking for open pipe, right? Open pipe, what is the frequency? Which fundamental frequency is V by 2L. Sir, V by 4L is this. So what would be V by 2L? It would be V by 2L is 2 multiplied by 512. It would be 102 hertz. Very good. That is done. Next one. 1 mole of an ideal gas at STP is heated in an insulated container until the average velocity of its molecule is doubled. Acha sir, what is the average velocity? Average velocity is going to become root 8p by pi rho, or root 8 rt by pi m, right? Now they are saying this is our V average. They are saying V average is doubled. So V1 by V2 equals to root, it is going to become P1 by P2. So V1 by V2, V1 by, it is 2V1 equals to P1 by P2. Let's square it, correct? So it is going to become 1 by 4 equals to P1 by P2. P2 is going to become 4 times of P1. So increases by a factor of 4. Now we are having a sound absorber attenuates the sound decibel by 20 decibel. Intensity decreases by a factor. So now we know that decibel intensity is given by 10 log I by I naught. What is I naught here? This is our threshold frequency for human beings. It is 10 to the power minus 12 watt per meter square, correct? So they are saying sound absorber attenuates the sound level by 20 decibel. So beta 1 is given, beta 2 is also given. This is, let's say this is I1, this is log I2 by I naught, and they are saying beta 1 minus beta 2 is how much? 20. So I am having here 10 log, it would be I1 by I naught minus I2 by I naught. This will be 20. So can I write it as log? It would be I1 by I2, right? And it would be 2. So can I remove the log? It would be I1 by I2 equals to 10 to the power 2, 100. So I1 is going to become, sorry, I2 is going to become I1 by 100, which is going to become basically decreases by a factor of 100, or the intensity decreases by a factor of 100. So we are getting I2 equals to I1 by 100, correct? Now next question we are having, a tuning fork resonates with a sonometer wire of length 1 meter stretched with a tension 6 Newton. So what do we have here? All right, so tuning fork is having frequency 1 by 12 root T by mu, and this is basically 1 by 12 root 6 by mu. This is R1. Then what are we doing when the tension in the wire is changed to 54 Newton? So its frequency is also changed. It is going to become now 54 by mu, and by doing that it is producing some beats, 12 beats per second. So now I have 1 by 12 root 54 by mu minus 1 by 12 root 6 by mu equals to 12. Can I write 54 as 9 into 6? Correct? 9 is going to come out, so it would be 3 by 12 root 6 by mu minus 1 by 12 root 6 by mu equals to 12. Correct. So what do I have here? 1 by 12 root 6 by mu, and here I have 3 minus 1, which is basically 2 equals to 12, correct? So this becomes 6. So 1 by 12 root 6 by mu, which is also the fundamental frequency, this is basically our 6 hertz. So that was all. Thank you so much. I hope you got all the doubts cleared. Thank you.